Hi, in this video we're going to look at the different configurations under which we can connect to AlwaysON. And when I mean configurations here, I'm talking basically about when you have a listener set up, when you have readable secondaries with routing URL set up, and also about automatic redirect, a feature that is going to be introduced in SQL 2019. And what we're going to do is we're going to just basically see what would the server name be under each of these configurations, and hopefully that'll clarify for us what happens when you try to establish a connection to an always on availability group, and how you can get an idea about if you're connected to the primary or the secondary, or under which circumstances you would be connected to the primary or the secondary. And this is again something that I feel whenever I introduce always on, a lot of people get confused, especially when it comes down to routing URLs and the way that they work in terms of the read intent, etc. And I figured that this would be a good time for everybody to kind of revisit the setup and understand how each different setting has a different impact as far as which database you're connected to and what operations you can perform on it. To recap, basically in Always On we have one primary and multiple secondaries. Again, the number of secondaries depend on which version of SQL Server you're using. And inside this, the primary is pretty much the only place where you can do read as well as write operations, and the secondary is the place where you do read operations. And whether you are allowed to connect to the primary or the secondary depends on things like the read intent and the configuration, etc. And that's what we're basically going to focus on in this video. At the end of the video, I'll summarize the entire scenarios in kind of like a grid format, which hopefully will make it a little bit more easier for you to recollect later on. So strap in and let's get started. To start off, we're going to try something very simple, and that would be a typical always-on cluster with availability group where we've got a SQL Node 1 and a SQL Node 2. And I'll just go ahead and open this up so you can have a look at it. So we've got SQL Node 1 and SQL Node 2, as you can see here. And I've got an availability group set up right now. So what you'll see here is, if I open up the availability group, you'll see that right now the primary is running on SQL Node 1, and in the primary I've got a database called test always on, and inside that I've got a procedure called what's my name, and essentially all it does is run at server name, and that will give us an idea about on which server we are currently connected. You'll see that I've got two nodes, SQL 1 and SQL 2, and I've got my database, and I've also got the listener configured. So let me just go ahead and show you this current always on setup, just so that we can remember this as we proceed further. So as you'll see, two nodes are there: synchronous commit, automatic failover. They allow connections at the moment, and I've made this read intent, so I'm just going to go ahead and make it read intent readable secondaries no for now. And I'll also go ahead and say that the read routing URLs, so you'll see that I've already configured routing over here, but because it's no, you'll see that at this moment there's nothing fancy happening here. So let that go ahead and take effect. In the meantime, I've got a website that I've hosted here, and on this website, as you'll see, I've got a button and a text box. When I click the button, the query gets executed, and whatever the server name is, that gets populated into this screen, or this text box. And this server this website obviously has a web.config, and inside the web.config I have my connection string. You'll see that in my connection string right now I've got application read intent, etc. So I'm just going to get rid of that. So the first scenario we want to try is what happens if you just type in the actual server name directly into the web.config. So if you type in the actual server name directly into the web.config and I click which server am I running on, you'll see that it shows SQL 1, and the reason for that is because SQL 1 is currently the primary. So no surprises there. As expected, I'm typing the server name, and because that server is the primary, and as it's a primary, you are allowed to read and write from it, therefore everything works fine. However, what happens if I type in SQL 2? When I type SQL 2 and then try to run this again, run the website again, you'll see that I get an error, and that is because the SQL 2 is now not a readable secondary, and therefore I'm not allowed to connect to it. So that's kind of expected behavior at the moment, where readable secondary not allowed and therefore not able to access. So let me just go ahead and make this now a readable secondary. So here we go. I say yes, and I say yes here as well. Press OK. And now that that takes effect, if I come back over here, if you notice in my connection string the server name is SQL2. So when I run this, now I'm connected to SQL2. So the bottom line here is, if you're going to type in the server name directly into the connection string, then you need to go ahead and make sure that readable secondary is set to true, so that in case of a failover or something like that, you still have some ability to go ahead and connect to the required environment. So bottom line here is that if you're typing in the server name, you will only be able to connect to the server if it's a primary. If you want to be able to connect to it if it's a secondary, then you need to make sure that it's enabled as a readable secondary. The next thing we want to do is, obviously this is not the way that we set things up. We always use a listener. And so I've got a listener that I've created over here, and the listener is AO test. So I'm going to go ahead and type in the listener name here now, AO test, and save that here. So at this moment my primary is SQL1. So when I execute this particular procedure, what's going to happen is, even though I'm connected to the listener AO test, it should connect me directly to SQL1 because that is the current primary. So as soon as I execute it, you can see here that SQL1 is what shows up. So the listener is automatically redirecting me to the current active primary, which again is a good thing for us. Next thing we want to do is we want to failover and see after the failover whether the listener will automatically redirect connections to SQL2, because after the failover, SQL2 is the new primary. Just give it a second. Great. So now SQL2 should be my new primary. As we can see here. Great. So it's a primary. And now if I go ahead and click the button, SQL1 should change to SQL2 because I will be redirected to the new primary from the listener side. And the reason why this is happening is because currently the application's default intent is read-write, and because it's a read-write intent, the listener is always going to redirect me towards the primary, and that's kind of expected for what we're doing here, because if you're going to do a read-write intent, you will be connected to the primary, and the listener will take care of deciding who the primary is and making sure you're connected to the right server. Now that we know how the listener behaves and how web.config or the connection string behaves depending on whether we type in the listener name or the server name, the next logical step would be to see how load balancing is achieved using read-only routing. And in this case, essentially what we're trying to do is if there is a read-write connection, we still want to connect to the primary, but if the user is trying to do a read-only connection, something that you might call a report or some data warehousing queries, things like that, then you might still prefer to do read-only routing, in which case the query is offloaded to the secondary server. Now, a thing that people often get confused about is wouldn't that just be the same as using readable secondary equal to yes? And the answer for that is it's different, because when you say readable secondary yes, you're only able to connect to the readable secondary if you actually type in the server name itself. So the problem that you'll face here is that your OLTP application is aware of failover behavior and therefore understands which is the primary, and because it's a read-write connection, it will automatically always connect to the primary and get the job done. However, your reports, if they are not aware of the failover scenario, just simply putting readable secondary doesn't mean that they will automatically be redirected to the secondary server where the select queries can run. So what we're basically trying to say here is that if you want the database to read only from the secondary, setting readable secondary equal to yes doesn't work. And the reason for that is because the listener is configured to always connect to the primary. And when you say readable secondary yes, what you're basically saying is I will establish a connection to the secondary database using the server name of the database itself. And if you type in the server name of the database, as you saw before, the problem that you face is failover scenarios don't necessarily work the way that you want it to work. And for a two node cluster, this might be easy to set up, but when you have multiple nodes, you want to go ahead and make sure that the node that you're connecting to is synchronized, is up to date, and by hard coding a connection string, you're basically not able to guarantee that behavior. So the next step we want to do is we want to go ahead and change the connection string and specify in the connection string that our intent as an application is to read only from the database. So essentially what we're saying is that we are going to run read queries, and therefore if this is a read query, the query needs to be executed against the secondary database. So you'll see in this case basically what we have here is I've got my SQL 2, and right now SQL 2 is the primary. And if SQL 2 is a primary, because I've specified my intent as read only, the connection, even though the listener is intending to connect to the primary, because it's a read only connection, the connection should come into SQL 1. However, to do that, I also need to make sure that I have configured the availability group over here and changing it from readable secondary to read intent only. This way it makes sure that when you're connecting to this machine, the intent of this connection has to be read only in a secondary role. So now that I've done both of these changes, if I go ahead and press which server am I running on, you'll see that I'm connected to SQL 1, and the reason for that is because even though SQL 2 is a primary, the read intent nature of my connection forces me to be redirected to SQL 1. The best way to test this is to remove this from the connection here, which means that the default is read write, and if the default is read write, when I click this, you'll see that it changes back to SQL 2 because SQL 2 is the primary, and therefore read write connections by default always go to the primary. A read intent always goes to the secondary, assuming you've configured everything else correctly, like how I just mentioned. And that's pretty much really the highlight of what we want to do in this video. We want to show how the different connections or the different configurations affect your ability to connect. There is one last thing that we need to discuss in this video, and that is a new feature inside of AlwaysON inside SQL 2019, where sometimes you don't have a listener and you still want to be able to assume you still want to be able to have a feature that automatically understands which is the primary and redirects connections automatically to the primary. This is especially useful for the scenario where we have readable scale out. It's kind of like the AlwaysON equivalent of mirroring, where we don't have a listener and we don't have a very high-end configuration like multi-subnet cluster or something like that. So in those kind of scenarios, we just want to be able to automatically redirect connections to the current primary without having to set up a listener. And for that, we have a feature inside SQL 2019, which we'll be demonstrating next. So if you remember at the beginning of this video, I demonstrated how typing in the server name may or may not work depending on whether readable secondaries were enabled. And what that meant was that if we go ahead and have a scenario say similar to this, where we've got the primary and then we've got the secondary, but the secondary is configured to be readable secondary disabled, then what happened was that when you try to connect to the secondary here, it fails. So as soon as we enable readable secondary, then we're able to connect to both of these machines. But again, bottom line here is that when you type in SQL 2, you're still connecting to the SQL 2 machine over here. And sometimes we want people to be able to redirect directly from SQL 2 to SQL 1, even though they have typed in SQL 2 in the connection string. And normally this job would be done for us using a listener. However, in this case we don't have a listener, so if you type in SQL 2 in the connection string and this guy is readable secondary equal to yes, we still want you to be able to redirect from SQL 2 to SQL 1 because that is the actual primary. So it's basically just another way of having the functionality of a listener without actually having to configure a listener in the first place. In order to achieve this, what you need to do first is you'll need to modify your existing availability group, as you can see here. And what we're basically doing is we're saying alter the availability group, and then on the replica SQL 1 we're saying that set allow connections equal to read write, and then the next command is to create a new functionality which is called read-write routing URL. We've already got read-only routing URL. Now what we're going to do is we're going to have read-write routing URL, and this guy points, as you can see, to the same instance. So you'll see that sql1.ebslive.com points to SQL1 and SQL1 over here as well. What this means is that on the primary role, the read-write URL should be always connected to SQL1. Now, to understand this further, what you can see here is I've removed from the connection string the read intent option. So this particular connection string now specifies that I should be connecting to SQL1, and SQL1 is, if you look over here, my secondary server. So I'm forcefully telling the website to connect only to the secondary server, and I am using a read-write connection, as you can see here. So when I do this, what happens is that if readable secondary is equal to true, it'll still connect me to SQL1. But I don't want to be connected to SQL1. I want my connection to be initiated towards SQL1 like this, and then from here, when it detects that this is actually a secondary, I want it to be redirected back to the appropriate primary. And that is achieved by basically running this script here, which is read-write routing URL. I guess the best way to understand this is to do it with the configuration setup. So let me just go ahead and show you this. So I don't have a read intent, and I am forcefully trying to connect to SQL1. However, when I execute this on the website, you'll see that it's actually forcing me to connect to SQL2, which is currently my primary. So the bottom line here is that what this guy is doing is he's intercepting my connection towards SQL1, identifying that it's a read-write connection, and then even though I don't have a listener, connecting me towards the current primary. And that basically allows us to go ahead and set this up in a way when configuring a multi-subnet cluster, which is kind of the most difficult part of setting up AlwaysON in these kind of scenarios. I've already initiated a failover, as you can see here. So now SQL2 is my secondary and SQL1 is my primary. So what I'll do is I'll now try to forcefully connect to SQL2 using a read-write intent, and when I do that, what's going to happen is, if you look over here, right now it's saying SQL1, and if you see here, SQL1 is my primary, so I don't I don't want to be able to connect to SQL1. I don't want to be connected to SQL2. I need to be connected to SQL1, even though my connection string says SQL2. So let me just go ahead and wipe this out from here, and I'll say which server am I running on, and it automatically, if you see, I was trying to connect to SQL2 and I'm not using a listener, but it still went ahead and redirected me automatically to SQL1. That's pretty much it really as far as automatic redirect is concerned. The idea being that with readable scale out we had the option of having a primary and a secondary, very much like mirroring. However, if we still wanted to go ahead and have an automatic failover and a redirect kind of scenario, we didn't have something ingrained or inbuilt into it unless we configured a listener. And as you remember in setups that we talked about, a listener was something that again required a failover cluster, etc., which might have been too much implementation for a very basic mirroring kind of setup. So what this automatic redirect does for us is it kind of rounds out our inability to have mirroring in the previous version of SQL Server, and now we actually have what you could think of as all the capabilities of mirroring inside of SQL 2019 AlwaysON, where we have the availability groups, we have the ability to sync, we have the ability to failover, and we have the ability to redirect users from the primary to the secondary automatically. And that kind of gives us all the capabilities that we need in a mirroring setup without having the big bang kind of AlwaysON setup that we were used to, where we had clusters, etc. So I hope this video clarifies a lot of doubts that you might have had in terms of how connections get redirected depending on whether you've got a listener, whether you've typed in the server name, whether you've got read-only routing, whether you've got read-write routing, etc. And hopefully it clarifies a little bit in terms of what the different server configurations, or what the different options entail in terms of where you end up connecting. To round this off, what I'm going to do is I'm just going to leave a couple of slides on the screen which summarizes what we've done in this video, and hopefully that should help clarify any doubts that you might have. If not, please feel free to go ahead and drop some comments, and I will get back to you as soon as I can. I hope you've enjoyed this video, and thank you for watching.